Hi friends, we have discussed introductory part of this moving charges and magnetism. Now let us go to the important topics of this one and very fundamental and important law. There are two in this chapter. One is called as Biot and Savart law. Another one is known as Ampere's circuital law. Let us discuss Biot and Savart law first. Consider a current carrying element xy. This is a current carrying element xy and I is a current flowing through this one. Current I flow this one. Here a small element delta L we consider. xy current carrying element and I is current through it. dl is a small element of this conductor delta L. Then from this element we want to find out, this is a point P which is at a distance r from this element, and we are interested to find out magnetic field at point P. And to find out this magnetic field at point P, Biot and Savart law gave one law. He says that magnetic field at B is directly proportional to current element, that is, it is I and then dl. This is called as current element. It is also proportional to sine of theta and it is inversely proportional to r square. So dB, the magnetic field here, is directly proportional to I dl, which is called as the current element. Sine theta, it is the angle, this theta, r and dl angle. This is the angle between r, that is the line joining point and center of element, and the direction of current. And then inversely proportional to square of the distance between dl and p. Here the proportionality constant, which is mu 0 upon 4 pi, is introduced. I dl sine theta r square. This mu 0 is known as a permeability of the medium, and value of mu 0 upon 4 pi is equal to 10 raised to power Tesla meter per ampere. Power minus 7. So this is the value of this mu 0, 4 divided by 4 pi. It is analogous quantity to 1 upon 4 pi epsilon 0. Now when sine theta angle is involved, it means that it's a cross product. So we write it, that is dB is equal to mu 0 upon 4 pi I dl cross r divided by r cube. I is displacement vector we call. So this becomes the Biot and Savart law in vector form. These all are vector quantities. We can easily see this one. dB is a perpendicular to both dl and r, because in vector quantity both of them are perpendicular. Now certain correlations or certain similarities of this Biot and Savart law with the Coulomb's law. First thing, both of them are long range. Both of them are long range forces. Biot and Savart law and Coulomb's law, both of them are long range forces. Second one, Biot and Savart law, in this also, dB depends inversely on r square, and in Coulomb's law also, both of them have a dependence on 1 by r square, or in both the cases, that is previous one electric field and here magnetic field has a dependence on 1 by r square. Third one, dB is also vector, electric field is also vector, therefore it obeys superposition principle. Both of them obeys superposition principle. Now in case of Biot and Savart law, ideally the element which is producing magnetic field, ideal is a vector. This is vector. But in case of Coulomb's law, the element which is producing field Q is a scalar. So these are certain points in this one. Next to this one, it is a scalar. Now, I is a vector. In this one, if you see dB, already I wrote dB is equal to mu 0 upon 4 pi I dl cross r2, and dE is equal to 1 upon 4 pi epsilon 0, that is Q divided by r square. Or if you want to write it, then r cube. Even though r cube is there, because of this r, both of them depend inversely on r square. In this case, there is an angle dependence. In case of Wyatt and Savart law, if sin theta is equal to sin 0, no magnetic field. Means along the displacement vector, if you see this one, if current and displacement vector, both of them are in the same direction, magnetic field is 0. In case of Coulomb's law, the electric field is not having any angle dependence. This is important in this one. Now, what the angle dependence indicates? That is, if this is a charge, then electric field is along the line joining point of interest and charge. It means that it is along the displacement vector joining charge and the point of interest. But in case of magnetic one, dB is a perpendicular to both. This is a current, it is dl, and this is point P. dB here is in this way. It is not in this plane, it is a perpendicular to both dl and P. It is either coming out or going in. These two laws gives you interesting relation between mu 0 and epsilon 0. What is this relation? Let us see now. We can take it. Relation between mu 0 and mu 0. Let us see. 4 pi epsilon 0 into mu 0 upon 4 pi, which is equal to, value of this one is 1 by 9 into 10 raised to power 9, and value of this one is 10 raised to power minus 0. 1 by 9. So it's getting cancelled. We get it epsilon 0 mu 0 is equal to 1 by 9 10 raised to power 16. If you see this one, this is nothing but 1 by c square. Value of c is t into 10 raised to power 8. Therefore, the relation which we are getting, c square is nothing but 1 upon epsilon 0 mu 0, or c is nothing but under root epsilon 0 mu 0. And I tell you, this one was later on discovered by James Maxwell. James Maxwell was a scientist who gave a set of equations to correlate magnetism and electrostatics. His equations are very famous equations, and later he also invented that light is nothing but it's an electromagnetic wave. It's a unification of three things. It's a magnetism, electricity and light. All these three things were unified by James Maxwell. Hertz, he discovered, or Hertz and discovered electromagnetic wave. They also produce electromagnetic wave. J.C. Bose, one Indian scientist, was also able to produce electromagnetic waves of few millimeter. Marconi is another person who has transmitted electromagnetic wave over 50 kilometers across British Channel, and that was the first wireless communication. Now this one, electromagnetic waves and radio waves were discovered somewhere in 19th century, but the development, landmark development happened in this research area in 20th century because of our understanding of production, transmission, amplification and detection of electromagnetic waves. See, all these four factors are important. Production, amplification, transmission and detection of electromagnetic waves. It gives the new opening of a complete branch of telecommunication. Today, I am able to transmit information to you by using these electromagnetic waves. Whatever I am speaking, it is far away from you. Physical distance does not matter here. It is transmitted to you. And all these things, this relation which is there, C is equal to 1 upon 4, 1 upon under root epsilon 0 mu 0 is a very important relation. That's all for this. Thank you.